So the first thing that we want to talk about are the basic structures of a loop. There's several of them that you can use. We're going to focus on two in this course, a for loop and a while loop. They're equivalent, one maybe more convenient over the other depending on your application, but there are other ways of looping in computer science. As needed, you're welcome to use other ones. The only thing you cannot do is use a go-to loop. I'm not even sure why we allow that to be put in languages anymore. So if you end up looking up on the internet and look up, there's a very famous paper called the go-to statement is, I think it's the go-to statement is bad. I might be using it, or considered harmful. I think that's what it is. But anyways, a very famous computing scientist wrote a paper a long time ago talking about how this was all over the place and it was bad. We shouldn't be using this as programmers. And people took this paper very seriously because this was one of like the fathers of computer science, one of the people who really advanced the field. And as we stopped using it, lo and behold, software became much, much, much better, more reliable, easier to update. And we have, well, not bug-free software, but we have much better things today because of that. So if you look up a go-to statement, I know that generally the policy is an automatic 0 at university. So we will ignore those. But other than that, any other loop that you use would be a legitimate one. So let's take a look at a for loop. Oops. Okay. So the reason I'm starting with a for loop is it gives you a lot of things right in the syntax that help remind you of everything a loop should have. So I'm going to write it here so you can see the pattern. This is the keyword in Java, for. Then you have a bracket, and you have some initial condition, some conditional, let's just say to execute the loop. And then you have a way of updating the conditional. So this may not make a whole lot of sense to you because you've never used a loop before, but it will make sense when you look back at it after we're done here and we plug these things in as variables and whatnot to program something. This is where your statements go here. So I'm going to show you a real simple loop. That's just going to print a bunch of things on the screen for you. So what I'm going to do is print a message a certain number of times. And this should immediately give you some idea of how a loop is useful. This is not possible to do without a loop or some mechanism for looping anyways. So here's what I'm going to do. First, I'm going to create the structure. And I haven't printed anything on the screen yet. So in this part here that says, what is the initial condition? That's where I'm going to say, to start with, I haven't printed anything. So printed equals 0. Then what I'm going to do is say, while printed is less than the number of times that they've asked me to do this, I will print a message on the screen. However, once I've printed it, I've got to update that and say a print has happened. So printed is equal to printed plus 1. And some of you may have seen this shortcut, so I'm going to use the shortcut. I'm going to call this printed plus plus. So in here, this is a basic console print if you do this in Java. System.out.println prints it to the console. It's very boring. It's not, this is 1980s, 1990s level of interface, but it gets the point across here. So I'm going to run this in Greenfoot so you can see what it does, but I'll just explain it one more time. A for loop has 3 things that are explicitly in the syntax. Every loop should have these same 3 things. You need to say, how does your loop start? What happens when things begin? So I haven't printed anybody, so I'm making printed equals 0. Now, if I'm allowed to go in and execute this code, this will tell me when the loop stops. As long as this is true, Java will now go in here and execute this code. Okay? Then Java will say, now that I've done something, how should I update the loop? Now I'm going to communicate to Java, I've printed one more thing, so I increment printed. And Java says, all right, I'm going to check, am I allowed to loop again? Then it'll go in here, print the message, update the condition, and check to see if it can loop again. And it'll keep running through in this pattern until eventually when it says printed here, it'll say, oh, I've printed it as many times as I'm allowed. I cannot go into the loop anymore because it's not less than how many I'm supposed to print. I've already used up all my prints. So I'll show you with our little ant here called Loopy. If I stick him in the world now, and I ask to print a message, I'm going to say print hello, and let's say 5 times. Now, it doesn't look like anything happened because Greenfoot pops up the terminal window here. But do you see what happened? There's 5 hellos. You cannot pre-program this. You don't know at runtime what the person is going to do. You cannot predict that exactly 5 hellos need to be printed. So you cannot just copy and paste the code. There is no way to do this without that mechanism. So again, when I go into my loop, that's what's being executed here is printing that message the number of times I've been asked. Now I'm going to take a look at a while loop with you. I will show you the syntax for a while loop, and then we will repeat the same method and show you how they're exactly the same, but a different way of explaining it. So it's kind of like a synonym. This is in your vocabulary for Java. This is learning a synonym for a for loop. So the syntax just goes like this. Okay, so a while loop, it doesn't have as much in it as a for loop. So for beginners, it can be problematic in that you forget things. If you forget something, for example, if you do not tell Java how to update your loop, that means it will run forever. Because whatever made the condition true never changes. It will be true forever, meaning your program is stuck, your window will freeze, and it will just print forever. So let me show you again what a while loop looks like, and we'll take a look at the difference. So public void, and I'm going to call this print message while. So I'll have a string for my message and an int for the number of times. And watch what happens. I'm purposely going to put an error in here. So a lot of the code looks very similar. However, something is missing. You might know what's missing because you can compare it to the for loop. I'll talk about how these things are equivalent and how you shuffle them around so that you know if you've used your while loop properly. But just think if you can predict what's going to go wrong here, and I'm going to run it for you so that we can have a look. But it's good that you see this because I promise you at some point you will make this mistake. I'll be perfectly honest with you too. I make this mistake still, because sometimes you run into this problem where you don't have the right condition to stop your loop. So if I ask my little ant here to print hello, and I'm going to say I would like it 5 times, the terminal is going to pop up. But you see, I don't know if you know what's going on right now, but the reason it's flickering is it's running forever. It's basically going and going and going and going. It hasn't stopped. And if I move the window here, you can see, look at it, it's way more than 5. This loop will never end because I never told it how to update itself. Right? It's a little more obvious in a for loop, only because in a for loop, you can see the thing that's missing. So here, this did not appear in my code. So that's what I'm going to do here is go printed plus plus. Okay. And I'm going to have to, I broke Greenfoot here, so I'll have to just pause it for a second. This is one of the reasons you don't want to do this. It's quite annoying to sort out your infinite loop. But now when I put in my ant and I ask it to print hello only 5 times, it stopped at the 5th, the way I wanted it to happen. So I'm going to show you the proper construct for a while loop. It's not explicit. A for loop, the reason it's explicit, it all goes in right there. But in a while loop, this is where you need to put your initial conditions. Before the loop starts, you need your Java code that initializes your loop. That's what I did here. When I start, I haven't printed anything. That's what happens when you begin your loop. Then, at the very end of your programming statements, update the looping condition. So what that means is, here's how I update my looping condition once I've done all of my Java. So the same 3 parts are there, but in a while loop, you have to make sure that you double check it so that you don't miss a spot. Okay, so I'll show you a few more examples of using loops. Your requirement will be to do both for and while loops. And as we set up our platformer game, you'll see quite quickly that we need this mechanism to write the platformer. Otherwise, we're going to have some difficulty with it. So let's try a few more just basic looping type exercises. So I'm going to make a method called SumEven, and you give me how many numbers. So I'll give you a little explanation of what maybe I want to do. The sum of even numbers. So SumEven 5, that would be 2 plus 4 plus 6 plus 8 plus 10. That's the loop I would want Java to run. Maybe I'll show you one more just so I can, let's try SumEven 3. That would be 2 plus 4 plus 6. So the output of that should be 12, and the output of this should be 30. So that's what I'm going to program in here. And as you get practice, right now I don't expect you to be able to write your code immediately after learning what the requirements are. But with some practice, you'll recognize where the repetition happens. So what do I see here? With SumEven of 5 numbers, that's how many I'm going to have. 1, 2, 3, 4, 5 things being repeated. When I sum 3 things, there's going to be 1, 2, 3 things repeated. So I'm going to go into my loop here, and I'm going to make this my count, how many things I've summed up. I'm going to say as long as the count is less than the number you give me, and each time this loop executes, I will have counted one more item. So in this problem, I have one other thing I need to do. I might be able to count the right number of pieces, but I still have to add them up. That's what's happening here. 2, 4, 6, 8, 10. You got to add them together. So I'm going to make something that holds on to that sum. So here I'm going to say int sum equals 0. I haven't added anything before the loop, so sum starts at 0. When I go into the loop, each time I'm going to take what it was before and add not the number itself, but 2 times the number. In here, I'll just rewrite this for you. It's even numbers. That's why I'm multiplying them by 2. Okay. And here is the count. 1, 2, 3, 4, 5. Okay. So at the end of this loop, sorry, I would like to tell you it, so I'm going to return that. So at the end of my loop, I will return the sum. So let's have a look here. I'm going to run this now and see. Hopefully some of you are thinking ahead a little bit about loops. I've been putting some buggy loops together to help you think about it. So let's just verify. I said sum of 5. It's supposed to be 30 according to what we talked about. It's not going to be. It's only 20. Anybody have a guess why it's off by 10? Yeah. Exactly. So what happens is when this loop started, it started at 0. But the way I'm counting it, it starts at 1. It could be different. Maybe that's what you think. You know, maybe this is the way your specifications are. And you're supposed to count 0. But usually we start the even numbers at 2. So I have to change this. My initial conditions to start at 1. And I keep going until I've hit the end of the count. So here, if I recompile, I should get the 30 that we originally had talked about. Okay, so I will ask you to sum up 5 and, oops, let me just have a look here. Got excited, I suppose. That's the problem as well. I mean, I meant to show you that. If I go from 1, I haven't actually hit the last number here. If you tell me to count up to 5, I actually need that 5th number. This is while I'm less than 5. So you're allowed to count up to 5. 1, 2, 3, 4, 5. That's why I need the equal sign in here, or my loop doesn't go high enough. So now, famous last words, there shouldn't be any more bugs. But let's sum 5 even numbers, fingers crossed, 30. Okay? So I'm going to give you another example here, and then we'll talk about expectations for you to do some basic warm-ups. Okay? But now I'm going to do compound interest. So compound interest, has anybody played around with this? Like, for example, how much money would you need to save for retirement? Or what would your savings look like if it grows 5%? You know, maybe there's no nerds out there big enough yet. Maybe one day. But someday this will be an important question to you. So what I would like is, I would like to know the value of an investment. So I would like to return that. So I'm going to return a double to it. And I'm going to call this future value. So you give me the initial value, the rate, and how many years. And I will tell you what it's going to be worth later on. So for example, there are formulas for this, by the way. I am aware of that. But to practice a loop with you, I'll just show you again one more time how this works. Let's just say I have $1,000 and I'm going to invest it at 5% for 4 years. Here's what happens. I start with $1,000. And that means this is how much I have after 1 year because you've paid me 5%. So this is 105% because that's what my investment will be worth after 1 year. Now this is 2 years, 3 years, 4 years worth of compound interest. Because however much money I have gets reinvested every year and it compounds. This is one of the reasons that credit card debt is so dangerous, because we're talking like 20% interest, and it keeps racking itself up against you every time you don't pay the balance. But let's just say 5% in this example one. So my first question to you at this very beginnings of your looping is can you see where the repetition happens? I didn't say can you write a Java loop. So just show me, hands up, I see where the repetition is. Maybe I'll... This is what Java is going to do for me, right? This is the math that I want Java to do for me. Can anybody looking at this line now, hands up, I see what's being repeated that I would like Java to do for me. Yeah, okay, so 1.05, that's what's being repeated over and over and over and over again. It happens 4 times because of 4 years. Those are the connections that you need to make in your loop so that you can now rewrite this. So this time I'm going to do a while loop with you, and just for some variety, and then I will convert it to a for loop afterwards so you can see the way the two have to work. Never will there be a time in a test quiz situation where I say write a loop that you must do one kind over the other. But in your exercises where you have time to ask me or a neighbor and you have that luxury of debugging and all that stuff, then I may put that requirement like 2 of your loops are a for loop, 2 are a while loop. So you do need to be fluent to both. It's not a huge leap between them. So let's start here. So again, think of things that need to start off. So for example, the future value. Right now, if I haven't made an investment, the future value is the same as the initial amount. So before I'm about to begin my loop, this is what happens. My future value is just $1,000 like the example one. Okay? There's years in this problem. It's natural that we count how many years we are at right now. So int year. And we're going to start at year number 1. Because at 1 year, I will apply this interest for 1 year. So if the year is 1 right now, that's where I'm about to start my loop. I'm allowed to keep applying interest while the year I'm on is less than or equal to the years I get to invest it for. So if you tell me 25 years, that means I get to go from 1 to 25. Okay? So what do I do with it? Well, that means I'm going to take the future value, and it's the future value times 1 plus the rate. That's what I did up here. It's the value times 1 plus the rate. The next year is the same thing. That's the value in yellow times the rate. Value in yellow times the rate. So this is going to keep multiplying on the compound interest. Now again, shortcut operator. It's a good one to know. Maybe you already know this one. You don't need to repeat future value equals future value times that. You can just call it future value times equals. Means the same thing in Java. All right. So what am I missing right now that's going to cause a problem? I'm going to have to shut down Greenfoot and start over. What haven't I reflected in this loop? So every loop should have 3 things. I've written them down at the top, so I'll say them for you again. Every loop needs the initial conditions that tell you whether or not you get to start, the conditions that tell you whether the loop will keep going, and how you update those conditions. So here's the initial conditions. Here's the looping condition. So I've forgotten to update this. So think about it in your head for a second, and I'll show you what it is. What do you think the condition's going to be that I have to now tell Java about? What has happened now that I've done this? The year has gone up. It's now another year because I've just given more interest to myself. Okay? So then at the bottom of this, I'll return my future value to the person who asked me. So I'll compile it, and I'll ask my little ant friend here about, let's see here. And I'll ask my little ant friend about the, future value. So let's say I invested $1,000 at 5% for 25 years. So what do you think? Anyone think it's over $1 million? No? Okay, well, let's see what happens. 3,086. So not bad. In those 25 years, it's more than tripled. Okay? We'll play with it just once here because it's not the point. This is for your math teacher, I suppose, more than it is for us. But it allows us to play around. Like, for example, what if the rate was... let's try 1.5 for 25 years. Wow, now you've made 32 times, almost 33 times your money by going up that little bit in the interest. So it might not seem like a lot, but that's why the interest is so significant. A guy like, anybody heard of Warren Buffett? Some of us? So a guy like Warren Buffett, I believe his track record is around 30-something%. So let's just say you were fortunate enough to invest. I don't know if it's 32 or maybe it's 18. I'm not sure here. We'll do a quick Wikipedia. Maybe I've overstated how awesome Warren Buffett is. It's Berkshire Hathaway is his company. Okay, there it is. 20%, 19.7. So I did exaggerate the Oracle of Omaha's, but let's just see 0.197. So if 25 years ago you'd invested $1,000 with Mr. Buffett, you'd now have $90,000, 90 times what you started with. So anyways, not that it matters to us, but the loop does. So let's go and take a look here. I'm going to pause the video, and again, my challenge for you is going to be, can you write this as a for loop now? Can you turn this into a for loop? And I will show you what the for loop looks like once we unpause. So to write our for loop, I'll just comment this out, and we'll rewrite the code. So to rewrite the for loop is more explicit in that it is now asking me for the initial condition. The loop itself is based on how many years have compounded this investment. So that is what should go into my loop. Everything that has to do with what year I'm at. So the initial condition is that I'm on year number 1. That's this part of the code here. How do I know if I'm allowed to loop again? The year that I'm on now is less than or equal to how many years I'm allowed to invest. And every time I loop, the years goes up. So in the while loop, here's me updating the year, here's me initializing the year, and here's the condition for it. So in a for loop, they all appear right there. It is possible to have more than one thing happening if you need that, but hopefully the most basic start we get is not necessary at the beginning. What happens in this loop now is, this is my statement I want to keep repeating, the one that's going to be executed many times over. But you'll notice this hasn't been declared yet, so that needs to go in here. Double future value equals my initial investment. Haven't applied any interest, same reason, it starts as the initial amount. Then I loop through it, and here I will return the future value of that investment. So this is the same loop, written as a for loop. And now when I stick our ant in, let's go have a look at Mr. Buffett again. 25 years. 89,609. Same as it was before, but written with a for loop this time. Okay? So, this I'll leave for you to have a look at, but the basic structure of loops is one of our key focuses for project number 2. And I'll put this code in this video up on our website so that you can refer to it for the next part.